And we're live. I feel like a TV star today. Welcome back, amazing people. And our final speaker today in the hall one is ready to present. There will be another presentation in hall five after this one. So just don't miss that one as well. My name is Yelena Sobolevska. I'm working for Accenture Baltics, and here today I am to present amazing people for you. And our last but not least speaker is Cristian Klein. Good afternoon, Cristian. How are you today?
Hello, thank you, and great to be at DevOps Pro.
You are from Sweden, aren't you?
I'm not originally from Sweden, but right now I'm living in and working in Sweden.
Did you become a hockey fan?
No, but I did pick up some winter sports like skating on ice and everything.
Oh, nice. Active person is always wonderful. We just here in Latvia, we have a hockey championship, and tomorrow we're playing with Sweden. And in Latvia, it's such a huge thing now. So it's
I see,
crazy.
I see.
When I see Sweden straight away, it's like, wow.
Mm, big stakes are tomorrow. I see.
It is. And two daughters you've mentioned as a physical activity. Was like
Yeah,
them.
they asked me to lift them up, and they like to ride me as if I were a horse.
That's a lot of activity for all the muscle groups. I agree.
Mhm.
Uh, if we think about diversity in IT world, are you teaching your two girls the programming and computer stuff?
They already had to program robots in daycare. So, of course, not very sophisticated programs, more like go left 3, go right, and so on. But then, once you click the play button, you cannot touch it anymore. Whatever you told the robot to do, it will just execute it. So, it counts as programming, I would say, for that level.
Yeah, so great. In Sweden, they already do it in daycare. Amazing.
Need to build a next generation DevOps specialists.
Yes, please, and females very important for any teams.
Mm.
So today you came to us with the topic how to operate and secure Kubernetes platforms. The stage is yours.
Thank you for the introduction. Hello, everyone. My name is Christian Klein. I'm a senior cloud architect and data protection officer at Elasticys, as well as an adjunct lecturer at Umeå University, and I was just said both are located in Sweden. I am passionate about cloud computing and data protection, and I am the product owner of Compliant Kubernetes. For those of you who don't know it, it's an open source CNCF certified Kubernetes distribution. It focuses on compliance with data protection regulations such as GDPR, such as the NIST directive, Swedish healthcare. And at Elasticys, we operate compliant Kubernetes for companies in health tech, ed tech, and in fintech on 5 EU clouds and also on-prem. Now, today I will talk to you about how to operate a secure Kubernetes platform. And to start with, notice that I'm using the term Kubernetes platform. This is because Kubernetes is really just an engine, but you still need to build a car around it. At the very least, you need to add some observability so that your monitoring and metrics are visible somewhere. You need to add some security, such as intrusion detection, such as automatic maintenance, such as network policies for proper firewalling inside your Kubernetes cluster. And moreover, Kubernetes is increasingly used to host additional services that your application needs, such as databases or message queues or in-memory caches. Therefore, I'm going to discuss Kubernetes-based platforms, where Kubernetes is, of course, an essential building block, but by far not the only component. And this leads me to what I like to call the Kubernetes paradox. Since its launch in 2015, it has become, let me just put it like that, Kubernetes has become easy and almost boring, right? Setting up a Kubernetes cluster is so much easier thanks to projects such as KubeSpray, such as Cluster API. And then not only the stuff under Kubernetes, but also stuff on top of Kubernetes has gotten easier. So now you have, for any kind of service you can think of, you have really mature Helm charts, you have various operators for databases, message queues, observability, whatnot. Nevertheless, I still notice that organizations out there are struggling to operate a secure Kubernetes platform. So I was wondering, why is this still hard when everything else is becoming easy? So today, I would like to talk to you about the top 4 challenges when operating a secure Kubernetes platform. Now, these are setting the scope, fostering the right alerting culture, making sure that you regularly train disaster recovery, and then also fostering the right maintenance habits. Now, to most of you, these might not feel like rocket science. In fact, to be honest with you, they are more like security hygiene and not security hardening. But trust me, you need to get these right before it even makes sense to talk about security hardening. For example, I saw some organizations that were very proud of themselves that were running for Falco for intrusion detection. But then I asked them, okay, so what do you do if you get an alert from Falco? At which point I was realizing that basically nobody was really looking at Falco alerts. So that kind of made the whole exercise of running Falco and intrusion detection pretty pointless. So that's why at the end of my talk, you will know how to get the basics right so as to have a solid foundation for your Kubernetes security posture, and then you will be ready to get security hardening right. Let me start with the first challenge that I notice, setting the scope. And in order to illustrate the problematic, let me start with a bit of an anecdote. Last summer, as I was having holidays, I was visiting my parents, and they showed me an engineering handbook from 1911. And it was actually quite an amazing volume, 3-volume of engineering. So it was like 3,000 pages, which literally contained everything that an engineer was expected to know in 1911, including stuff such as how do you compute the strength of various steel profiles, and how do you design a car so that the engine output is the one that you need. Now, I think that nowadays people don't just go to engineers, but rather they would go probably to an electrical engineer to build a circuit, and they would go to a automotive engineer to build a car, and they would go to, I don't know, a civil engineer to mix concrete, right? In the meantime, society has understood that, well, there's simply too much engineering knowledge in order to fit in just one person's head. Unfortunately, I still see organizations treating software engineers, and in particular DevOps professionals, pretty much like that. They expect them to be knowledgeable in everything from user interface design to storage cluster administration. And there's just too much knowledge out there for each of these technologies to fit in the head of any single person, especially if you expect that one person to be good at troubleshooting issues with each of these systems out of muscle memory at 2 a.m., right? It's one thing to be Googling around, how do I do this? And then doing that at your own pace. And it's a completely different thing to, immediately recall what are the correct commands to type to investigate, a storage cluster, which is unhealthy, or a Kubernetes cluster that lost quorum, or a database cluster that suddenly needs to be disaster recovered. Completely different pace, completely different stress level, completely different level of how well do I need to know these things. So yeah, this image pretty much highlights it all. We have a lot of technologies, we just call them DevOps, and we expect people to know all of these things. So my first recommendation is to instead scope your technology stack into smaller and more manageable pieces. And generally, I like to think about the tech stack as belonging to the application team, which sits on the very top, very close to your customers. Then you have the platform team, and then just below it, you have the infrastructure team. And I have seen very many ways to doing scoping out the tech stack properly. In some cases, for example, the platform team was rather higher up the stack, and they were responsible, for example, for developing application boilerplate to deal with stuff such as sick term handling, or making sure that applications are properly using structured logging, or making sure that applications are having a metrics endpoint, and pretty much making the application team only focus very high up in the stack on the business logic. I have also seen other ways of scoping the stack where the platform team was rather lower, very close to the infrastructure, and they were also responsible to, taking care of a storage cluster which was on top of some VMs. My point is that there are many ways to scope things that make sense, as long as the scope is clear to everyone and as long as you assign the right skills to the right task. The way I like to imagine this is that, like I said, you have your users who are customers to your application team, who are customers to your platform team, and then who is customers to your infrastructure team. And in fact, creating a clear customer-supplier relationship is one of the benefits that I see in getting scoping right to avoid, the circular dependencies between the teams. But there are also other benefits to getting scope right. First of all, it avoids blame games. It avoids the kind of issues where, well, I thought you would do this and you thought I would do this, and then in the end, none of us did that, right? It's so easy to, for example, think, well, I thought you would do backups, but you thought I would do backups, and then suddenly your backup scope doesn't include some critical data. But it also empowers the platform team to take the right decision within their scope. So, for example, if a platform team says, you know what, we are responsible for keeping the Kubernetes platform secure, and we assessed that we do not want to run continuous root, that's fine. Then that's their decision. They're responsible for security within that scope, and it's a decision they can take without having to negotiate too much with everything around them that happens. And finally, it also assigns the right skills to the right task. And here, in case you are having a security officer or if you're subject to some kind of audit, also remember that this makes the auditor happy because they tend to be very quick at picking up if you're having way too few people allocated to do way too many things at once. And for example, the way I like to think of scoping is that within the scope of the Kubernetes platform is the Kubernetes cluster itself, but also all the pods need to make the Kubernetes cluster secure, observable, and stable. I would say that the continuous delivery tool is also something that can be in scope, and then additional platform service such as database, message queues, and caches. And the example that I'm just giving you here, it would be outside the scope of the Kubernetes platform, for example, application code and pods. This would be in the scope of the application team. The code that is taking care of continuous delivery, the configuration as it's called sometimes, would be also outside the scope of the Kubernetes platform. Continuous integration code and tooling in identity provider, and then also the infrastructure would be also outside the scope of this platform. And while it's very important to stay within your scope, it's also equally important to kind of still be mindful about the things that are outside the scope, because that allows you to interact well with those teams. So, for example, too often I saw that people are trying to succeed with Kubernetes when their application doesn't tolerate node restarts. And if there's anything that you know as a Kubernetes administrator is that you need the application to tolerate node restarts, you need to have, pod topology spread constraints, you need to be replicated, you need to gracefully restart, because otherwise you cannot reboot the nodes you cannot drain the nodes, you cannot reboot the nodes as required to do proper maintenance. Or at some point, we also discovered, for example, that, well, the platform team was expected to offer 24/7 support for the Kubernetes platform, but the infrastructure team was actually only up between 6 and 22. So then, of course, there is, again, a misalignment between the security goals of the two teams. And each time you discover one of these deviations, each time you're deviating from these good principles, that would make it so much harder to secure Kubernetes and to work with Kubernetes, and would pretty much feel like you're not really leveraging the benefits of Kubernetes, and you just need to work against Kubernetes. So it's a very good thing to, be mindful about the things that are outside the scope and to help adjacent teams to help you make the best out of Kubernetes. Now, the second challenge that I've noticed is alerting culture. And this is also very paradoxical because setting up alerts is super easy. Seriously, if you have no clue how to set up alerts, just take Prometheus, which is the go-to project, go to this website, awesome Prometheus alerts, and you find amazing alerts for things such as alert me if I'm running out of disk space in 3 days using linear projection and things like that. Nevertheless, I noticed that alerting is still rather hard. Why is that? Well, because alerts are really only as useful as they're being given attention. In fact, by definition, an alert is pretty much the platform saying like, hi, I need human attention now. And if alerts are not being done properly, then this pretty much leads to a crying wolf phenomenon, or alert fatigue as it's sometimes called, where where even important alerts eventually get missed and get ignored. So why is alerting necessary? Well, to your CEO, just say that you need to do this properly in order to avoid disappointed customers, expensive files, or jail time. Yes, I actually said jail time because recently it has emerged that at least one CEO was sentenced to a 3-month suspended sentence for neglecting security in a health tech company. So, if nothing else, convince your CEO to allocate the time to tune your alerts. Maybe this will convince them. Your CISO or your data protection officer, they know that certain regulations require an incident management process. So then you can just argue for alerting being part of this process. And for your team members, if you're part of the platform team, it just gives you a very good feeling of avoiding unknown unknowns. It gains confidence, and yeah, I'm pretty sure that stuff doesn't work because, I'm really sure that stuff works because I know and I can rely on the fact that if it doesn't work, I get an alert. So how exactly do we do alerting properly? How do we foster the right alerting culture? Well, first of all, we need to distinguish between P1, P2, and P3 alerts. We need to have a clear alerting workflow, and we need to empower the team to tune alerts. So let me start with the first part, P1, P2, and P3 alerts. Now, nomenclature differs a little bit between teams and what systems you're using. So don't focus so much on the terminology, but rather on what they try to capture. But let me just use this terminology because it's a good starting point. So I call P1 alerts those that need attention immediately, or sometimes they're also called 2 a.m. alerts. These are mostly relevant if you need to keep Kubernetes secure and stable outside of office hours. And they should only be reserved for those events where downtime or data loss is imminent. Example of such alerts could include, etc quorum has been lost, disk space is full and I cannot write anymore, or for example, PostgreSQL is suddenly having a split brain condition and you have 2 primaries and, data loss is imminent because you never know, the application doesn't know to which primary it should write and which primary synchronized to which other primary. Now, P1s are, like I said, absolutely needed, but try hard to avoid them. And there are 2 ways to avoid them. First of all, by investing in redundancy, having 3 control plane nodes, having 2 replicas for all of your deployments, making sure that you have the pod topology spread constraints so that pods don't end up on the same node. So in case one node goes down, you really want your at least one application to pod to still be up. And here I have some good news that actually Kubernetes 1.25 ships by default with some decent cluster-wide pod topology spread constraints. So you kind of get them for free if you are running the latest version of Kubernetes. And this, the way the default pod topology spread constraints are configured also ensures that your pods are getting spread across zones in case you are running a multi-zone cluster and you have labeled the nodes accordingly. Redundancy is one way to avoid P1 alerts. The other one is predictions. So, for example, in Prometheus, you have the predict linear function, which allows you to do linear predictions and create alerts such as alert me if disk will be full in 3 days. And I know that when it comes to redundancy, especially 3 control plane nodes, that might clash a little bit with being cost conscious, especially now in the times of bad economy. But the argument I'm trying to push forward to everybody is that, well, VMs are cheap, disturb sleep, and engineers that are unhappy because they constantly have to wake up due to incidents is way more expensive than those extra VMs that you need in order to have a redundant control plane. Now, in my experience, as much as one tries to, one still cannot completely avoid P1 alerts. But what you can do instead is at least make them a lot less stressful for the on-call person by providing a clear workflow. If I'm on call, I need to know, out of reflex, what do I need to do? And what we usually do is that we recommend having something like a nighttime workflow and then a daytime workflow. At night, you pretty much need to very quickly decide, should you troubleshoot the cluster and fix the problem? Should you just silent the alert and go back to bed? Or should you escalate to your team manager because this is something very serious? So for example, if you suspect, I don't know, a breach, you see suspicious network traffic, or you see suspicious CPU usage, which indicates that maybe you have a data breach, then it's better to wake. Trust me, your engineering manager will be happy that you woke them up in order to escalate this, rather than having to deal with this issue by yourself. And then during the day, you can take things a lot calmer. You can, ask somebody within your team, hey, do you have a better idea what could be wrong? You can perhaps go to some go-to person that knows the subsystem a little bit better. You might actually take a little bit more time and Google around and better understand the core issue. And there you can actually, fix the problem and maybe improve your platform and roll out a new fix, as opposed to just, patching it quickly to survive the night. Now, then we have also P2 alerts, and I like to call these needs attention within a business day alerts. Now, the thing is that these are still disruptive. Your platform engineers won't be able to do development work. They won't be able to, develop your platform and improve it. So they're still kind of disruptive for the working hours. However, they're not disruptive they're not ruining evenings, they're not ruining weekends, and in particular, they're not ruining sleep. And also, since other team members are usually awake during office hours, these alerts can be taken slowly and calmly. Examples of P2 alerts include Kubernetes node went down, this under assumption that you have sufficient redundancy so your cluster tolerates one node failure. Persistent volume will be full within 3 days. Host disk will be full within 3 days. The PostgreSQL primary failed, but don't worry, the secondary was promoted to primary, so it's okay. Or, for example, a nightly backup failed, right? It's not ideal, but it's not a reason for being woken up to, just reboot a cron job or whatever. And finally, we have P3 or review regularly alerts. These are really alerts that you cannot really act on them immediately because they feel very, let's say, confusing and non-actionable. But hopefully, if you collect enough of them and you regularly review them, eventually you see a pattern that emerges and then they become actionable. So this could be things such as a pod has restarted, but this happens only rarely. Or you have some kind of pod that is CPU throttling. We had this, for example, for Fluent, the log forwarding solution was throttling every now and then. We didn't quite know why. We did not quite know, does it need more capacity or not? But eventually, as we collected more P3 alerts, we could see a pattern emerging, and we knew that, yes, indeed, it needs more capacity, and we rolled that out across all our environments. Or, for example, Fluent log buffer went above a certain threshold. No logs were lost, but it's still a little bit weird that Fluent's buffer got used to that extent. So that maybe suggests that there is some kind of congestion or some kind of capacity issue upstream from Fluent. Now, I often get asked, but how do I know if I should classify an alert as P1, P2, or P3? And here my standard response is, well, engineer for change, not for perfection. What I mean by that is that you're not going to get these things right. So it's just better to empower the team to tune alerts and to reclassify quickly alerts from P1, P2, P3, depending on the environment, depending on a namespace, depending on the image, and so on. And in our case, our approach is that our Kubernetes platform over alerts. So it really sends all of the information it can about a particular attention-worthy event to our on-call management tool. And then it's in this particular tool, say OpsGenie or PagerDuty, where we do prioritization and silencing of these alerts. And we do it like this because we just felt like the on-call management tool is a little bit more intuitive, and it allows our team, it does a better job in empowering our team to prioritize or silence alerts as needed. I sometimes get asked about, so how do you technologically implement proper alerting? And let me just reassure you, if you're using Kubernetes and cloud-native tools, such as Prometheus, Thanos, and Grafana, it's, to be honest, pretty simple. The only thing I want to show you in this diagram is that we actually have two different alerting subsystems. One which is alerting the application team for things that are within their scopes, such as pod got restarted or certificate from the ingress didn't get renewed and things like that. And then we have alerts within the scope of the platform team, such as a system pod got restarted, or, for example, the container registry, which is their responsibility, has a certificate that is about to expire, and so on. Let me now move on to the third challenge I noticed for operating a secure Kubernetes platform: disaster recovery training. Now, why is disaster recovery training necessary? Well, I keep reading the news about the latest organization that got hacked by some kind of ransomware attack, and I keep being surprised, like, why are organizations not able to cope with these attacks, and why do they sometimes prefer to pay the ransom? And when I'm checking the articles a little bit more in deep, I realize that these organizations are confusing "we do backups" with "we know how to predictably restore from backup in a certain bounded time interval." And the two are quite different, right? So what I'm trying to suggest here is that simply saying "we do backups" is today no longer enough. You actually need to go in and regularly try things out. And the way I like to compare this to is think about flights, for example. Pilots are spending countless hours in flight simulation training, testing various failure scenarios like, an engine failure or flaps cannot be retracted and things like that. But quite often it happens that some of the pilots are going through their whole career without any flight incident. Why are they spending so much time in training? Well, because incidents can be stressful, and so you want really to have your mind prepared and to know exactly what you need to do. You want to be familiar with that situation. And that's pretty much the reason why we also need to do disaster recovery training when it comes to Kubernetes platform. Incidents are stressful. Often disaster recovery of these systems is complex, which adds to the stress, especially as your platform is offering more services, more additional managed services, is running on trickier clouds, and so on. It also helps to train, to boost the team confidence and morale, because this makes sure that the team knows that there's always a way out. No matter how bad the incident, no matter if you lost etc quorum and you don't know how to recover from that, there is a way out to get the system back on its feet. This also allows you to measure the recovery time objective, and I'm going to talk about some important timelines when it comes to disaster recovery in the next slide. And if really nothing else, or I'm pretty sure that you're convinced to do disaster recovery training, but if you're struggling to convince your bosses to allow you to prioritize properly disaster recovery training, just tell them that this is really mandated by some regulations. So this will be mandated for many, many providers who will fall under NIS 2. And then if you're, for example, somebody who is dealing with patient data, for example, in Sweden, we have the Swedish patient data ordinance, which very clearly tells you that you need to do a risk assessment and you need to decide on what interval you do disaster recovery training, and you actually need to make it happen, right? So technically, if you're not doing this, it's kind of like you're operating your company illegally, a bit like not paying your taxes, if you will. So let me go a little bit more into details about the timeline of a disaster. So generally, you will have a point in time, which is your latest backup. So this is the oldest data you can restore. You will have then a point in time, which is the earliest backup, the newest data that you can restore. You might have a gap between that and the disaster, and this is the RPO, your recovery point objective. And then you need some time to actually recover the system from a disaster, and the moment of time when it's fully recovered, that's called the recovery time objective. And there are some weird forces that are working for and against each of these times. So, for example, the latest backup, of course, you would kind of want to make it as late as possible so they can restore whatever data you want. That minimizes data loss. However, recall this thing called GDPR and right to be forgotten. Well, if you have really long backup retention times, that makes it very difficult to forget, because in a sense, you need to remember to forget about those people that you have forgotten. And then similar with the earliest backup time, of course, we would like to keep our recovery point objective as short as possible, but generally having it very small requires to do very quick or incremental backups, which tends to be at some point very expensive. So these are the forces that are, data loss minimization, right to be forgotten, and backup costs. These are the forces that are acting on these, on the backup retention and the recovery point objective. And these are simply things that you need to negotiate with your CISO based on recommendations that you are giving them. And then once you decided on these objectives, then honestly, implementing backup in a Kubernetes platform is rather easy. You have, in essence, two choices. Either you're going for a generic solution, such as Velero, which can back up Kubernetes resources and also persistent volume claims. And it's rather application agnostic, which is nice because then you can have only one tool to learn. On the other hand, you can have some application-specific backup methodologies, such as, for example, if you're using OpenSearch, that has its own way to do backups, or if you're using Harbor, that again has its own way to do backups. That has the advantage that it tends to store less application state because it knows exactly what needs to be stored and how it needs to be restored. But on the downside, it means that every single time you have an application-specific restoration method, that just makes your disaster recovery script runbook longer and longer and more complicated. I recommend everyone to store backups on S3 compatible object storage. And the reason for this is because it is simply more reliable than any file systems. It tends to be more cost effective. It's very easy to synchronize. For example, using something like rclone to synchronize it to an offsite location or to an off-cloud location. And rclone can even encrypt those off-cloud backups using some encryption key that you provided with. And also S3 compatible object storage is widely available on US cloud providers, on EU cloud providers, or on-prem. So, wherever you're running your Kubernetes platform, you're likely to have object storage. And then you also need to think about how to make sure that you're protecting your backups so that you're not losing them and you can truly recover from them. And here I recommend to use 3 ways of protecting these backups. First of all, some S3 compatible object storage supports so-called object lock, where you can actually say, I don't want this object to be able to be deleted or modified within 30 days. Not even I am able to do that. So this, of course, means that even if the production environment is fully compromised, an attacker cannot just go and remove backups with the access they are given from the production environment. And of course, who would have known data centers can burn? Happens to US cloud providers, happens to EU cloud providers. And in that case, it's a very good idea to do offsite replication or even off-cloud replication to make sure that your backups are well protected, both against attacks, but also against data centers going down. I have been asked, how exactly do we conduct these disaster recovery drills? So here are a few tips that hopefully help you get started with this habit and, make sure that these drills are happening. First of all, you need to decide on a frequency, such as let's do it quarterly. Then you need to decide on some goals, what you actually want to achieve from these disaster recovery drills. And goals could include things like ensuring that the runbooks for disaster recovery are up to date, but also, for example, to measure our recovery time objective to actually see that it's within the stated target. You need to decide who is going to do the disaster recovery drills. So this could be, for example, the whole team, or if you want to do it a bit cheaper, maybe half a team, so that basically if you do it quarterly with half the team, then every team member gets 2 disaster recovery drills every year. You need to then decide what was the state of the environment before the disaster, and you need to come up with a scenario for the disaster. For example, you can say, well, the application team complains that they lost metrics. Please investigate and worst case, restore the metrics. And then do reserve some time at the end of the disaster recovery drills for a retrospective. What went well, what went wrong, how to improve. And based on that, you can make a concrete list of action items that you can then, schedule in your sprints, or if you're using Kanban, calmly schedule and work on to only make your disaster recovery posture get better and better. We have done quite a few drills ourselves, and the common issues that we have encountered were, first of all, that the application team was uncertain about the backup scope. They were uncertain, like, do we back up persistent volume claims? Do we back up Kubernetes resources and things like that? So just to clarify this with the application team proved to be a huge benefit of these drills. We also had cases in which the application was simply not recovering properly after a restore and needed a few more manual recovery steps to make sure that it recovers from a disaster recovery. And, if you're discovering this during a drill, that's fine. You're just documenting these steps. But if this happens at 2 a.m., then, of course, it's very stressful because maybe the application team member who knew about this quirk is actually on holidays or is sick or whatnot. We also noticed that there are a few gotchas in the way Velero does restoration. For example, a service account token didn't get restored in certain conditions. In our case, the impact was not that big, right? We just needed to make sure that after each restoration, we fix something with the continuous delivery integration. But it's a good thing to know, like I said, during the drill and not at 2 a.m. And then we also noticed that Velero sometimes restores resources in what we would see as the wrong order. So, for example, we require all of the deployments, all of the pods in a deployment to be selected by network policies, whereas Velero might restore deployments before it restores network policies. And of course, our Kubernetes platform was rejected this as a compliance violation. Let me now go to the last challenge when it comes to operating secure Kubernetes platforms, maintenance. And let me just take the time to notice that we seem as a species to have really a huge issue when it comes to maintenance, right? I mean, we're not having venture cup for maintenance, like, wow, the biggest maintenance project. We're not having news with, yeah, now this bridge got maintenance. The only time that maintenance really gets celebrated or not celebrated, but gets enough attention, it's when it's lacking, when bridges are collapsing, when buildings are collapsing, and so on. And one would hope that platform engineers do a little bit better than civil engineers. But in fact, there was a report by Datadog on the state of the containers. And this was back in 2020. And the most popular Kubernetes version that was run at that time in production by most organizations already had reached end of life. So it doesn't mean that people were running an insecure and unsecure patched Kubernetes version in production. It means they were running a version that was not even receiving security patches. Needless to say, this puts data at great and unnecessary danger. So in order to avoid that, do foster good maintenance habits. And I suggest you not to jump directly on the GitOps bandwagon. Rather, start by doing it manually and just focusing on cadence, right? Make sure that it actually happens. I don't know, book that time slot in your calendar or make sure that somebody does it once a month. And once you figure out cadence and it kind of happens regularly, then focus on predictability. Make sure that maintenance is becoming more and more boring and that it just becomes tedious. There are no exceptions, there are no special cases, no nothing. And when you reach that moment where people are really bored of bored of maintenance, that's when you can start thinking about how do I automate this process. Now, a few tips when it comes to automated process. There are very many good solutions for doing this, but here are the things that work for us. So we really had to think about maintenance in terms of layers, and then for each layer kind of have a different solution for maintenance. So when it comes for the base operating system, things like the Linux kernel, the container runtime, the kubelet, what we're doing is that we installed a package called unattended updates on Ubuntu. And then we're having a project called QRD, which is carefully checking if any of the system packages requested a restart. And if yes, then it cordons, it takes a lock on the Kubernetes cluster, it drains the node, it reboots the node, it then uncordons the node, and then releases the lock, right? So it makes sure that your Kubernetes nodes get restarted very carefully, making sure that there is enough capacity in the cluster. And I kind of find it satisfying because it also serves as a sort of a chaos monkey, right? Your application needs to tolerate node replacements because otherwise it will just notice all of these base OS updates. Another way to do it is to just simply replace the nodes by using something like Cluster API. And then for system pods, we use Tecton, but another good solution would be Flux. And for the application pods, we recommend Argo CD. We have encountered quite a few maintenance issues ourselves. One of the most common one is that simply the application has insufficient replication, so it doesn't tolerate node replacements. And then the solution is pretty simple. Just make sure that the application is having enough replicas, and hopefully it has been engineered without too much. So hopefully it has been engineered in a way that the state is in databases or in message queues, which then you can treat a lot more carefully while you're doing maintenance. Another issue that we encountered was that draining was taking too long. For example, because an application pod was not listening to SIGTERM, or it was relying on a timeout to get killed. Sometimes we had situation with draining was not possible because some application developer, deployed a Helm chart with some kind of pod disruption budget, which essentially said this application has exactly 2 replicas and both of them need to be up, and that makes it impossible to drain. And finally, we had a situation in which there was simply not enough capacity in the Kubernetes cluster to drain a node and to find other nodes that can take those pods. So to sum up, make sure to set the scope correctly to clarify what your platform team needs to deliver and what it is provided with. Foster the right alerting culture to ensure that your team is aware but not overwhelmed with symptoms which may lead to security and stability problems. Practice disaster recovery to make sure that your team can always recover even from the worst incident to a known good state, and then foster the right maintenance habits. If you like my presentation, consider following me on LinkedIn, where I regularly post on Kubernetes, security, and data protection. Thank you very much for your attention. I'm ready to receive questions.
Thank you very much, Cristian. Thank you for your amazing presentation.
Thank you.
So the delay is around 10 seconds, so we wait a bit till it finishes at the past where actually all the listeners are now. I'm really enjoying this. I feel like Back to the Future kind of movie.
Mm-hmm.
So we can see if there are going to be any questions. But looks like all presenters are so good at their explanations today. I didn't have any single question in the end, like thank yous and stuff. But yeah, it's like, no, it's clear,
Or maybe people are just too shy to ask questions publicly. But feel free to also shoot questions on LinkedIn. I'm happy to answer, depending on subject to my bandwidth, if people are too shy to ask the questions publicly.
Actually, yes, here in Baltics, we are kind of shy people nations. Mm-hmm. And when it was COVID and they made a rule, this 2-meter rule, mm-hmm. We had a joke that people in Baltics went like, why do I need to come so closely to people?
Yeah.
Yeah, that told us a lot about Baltic
mm-hmm,
states.
Mm-hmm.
Is it your last presentation for today?
Yes.
And it was 2 days for online presentations, and tomorrow and day after it's gonna be on premises. So another level of activity for Lithuania people.
Yeah, that sounds really exciting. Unfortunately, I couldn't join this year, but hopefully I will be able to join next year. But yeah, it sounds so exciting to see all the people and to interact with them at a different level and have the hallway track.
But still, a big thank you to organizers for keeping the hybrid option, because a lot of speakers wouldn't be able to come because, family traveling, it's too much effort and investment of time and stuff. But in this, we could get all the knowledge of the people who are remotely, and that's very good.
I agree.
So no questions, everything was super clear, and yes, please contact Cristian on LinkedIn if you need something, clarification or some other knowledge, while he's so kind and offering. Thank you very much for your time. Thank you
for having me.
Yes, and see you around the next conferences.
Yeah, see you around. Enjoy the next 2 on-premise days.
Thank you. Bye-bye.
Bye.
This is all we got. Remember the revolution in our minds. This is all we got.
Lock me out of this life institution. I am angry and high on illusions. Yes, I hate, but it's not a solution. Try my best, but I'm just a human. Oh.